Hi, welcome to this Blender video tutorial entitled Cloth Simulation. As we've seen in previous video tutorials of this lesson, it's possible to simulate cloth using Blender's soft body dynamics. However, Blender has an additional physics dynamics called cloth that is especially designed to simulate cloth objects. Although Blender's cloth dynamics, like soft body dynamics, allows external and internal forces to affect an object's vertices, it provides a considerably better resolution. To demonstrate Blender's cloth simulation, I've modeled in my scene a simple chair object resting on a plane object. Above the chair is another plane object that has been smoothed. I'll select the upper plane object and tab into Edit mode. As you can see, I've subdivided this upper plane a number of times, making it a vertex-dense mesh. I'll tab out of Edit mode and select the lower plane object, and in the Physics Editor, add a collision detection. I'll also add a collision detection to the chair object. I will select the upper plane, and in the Physics panel, I'll make it a cloth object. I'll accept the default cloth settings and play the simulation. The plane's vertices fall down along the z-axis and conform to the chair object below. You can already see that the resolution of the cloth simulation is much better than that of the soft bodies. I'll stop the simulation and go back to frame number 1. In the Physics Editor, there are a number of different panels associated with cloth dynamics. Many of these controls are similar to those found in soft body control panels. One important control is the preset drop-down box located in the cloth panel. In practice, Blender modelers will select the preset that suits their needs the best and then make slight control adjustments from there as needed. I'll select the cotton preset and play the simulation. The cotton preset is a fairly loose cloth with a low mass setting, a moderate structural setting, and a low bending setting. I'll stop the simulation and go back to frame number 1. I'll select the denim setting and play the simulation. The denim preset has a higher mass, more structure, and more bending, and much more spring damping. I'll stop the simulation and go back to frame number 1. I'll select the leather preset and play the simulation. The leather preset has twice the structure of the denim and 15 times more bending. I'll stop the simulation and go back to frame number 1. I'll select the rubber preset and play the simulation. The rubber preset is much like the leather, but it has much more mass and much less bending. I'll stop the simulation and go back to frame number 1. I'll select the silk preset. The silk preset is the finest of the cloth presets. It has very little mass, little structure, very little bending, and no spring dampening. I'll stop the simulation and go back to frame number 1. I'll tab into Edit mode and go to Top View. I'll open up the Object Data Editor and in the Vertex Group panel create a new group named Group 1. I will box select the top group of vertices and assign them to the group. I'll then tab out of Edit mode and go back to the Physics Editor. In the Cloth panel, I'll checkmark the Pinning checkbox, and I'll select the Group 1 vertex group from the drop-down box. The pinning function removes the external force effect from the selected vertex group of vertices. This remove can be tempered by the stiffness setting. A level of 1 removes the cloth effect completely from these vertices. A level of 0 makes a selected vertex group completely affected by the cloth effect. I'll select the rubber preset and then play the simulation. The pinned group of vertices remains stationary while the rest of the object vertices fall down along the z-axis. I'll stop the simulation and go back to frame number 1. I'll remove the cloth dynamic from the upper plane and remove the collision from the chair and the lower plane. I'll then go to layer number 2. Here I have a rectangular plane object that has been smoothed. I'll tab into Edit Mode. As you can see, I've subdivided the object a number of times, making it a dense mesh. I'll zoom in a bit on the top of the plane. Here I will select every fourth vertex running along the top from left to right. There are 34 columns of vertices here, so I'll be selecting 12 in total. I'll then open up the Object Data Editor, and in the Vertex Group panel, create a new group named Group 2, and then assign the selected vertices to that group. I'll tab out of Edit Mode, and I'll rotate the plane object 20 degrees about the y-axis. I'll then tab back into Edit Mode. I'll then select an outside vertex about halfway down the plane. I'll then box select a group of vertices parallel with the selected vertex. I'll then assign these vertices to Group 2. I'll then press the A key to deselect the vertices and tab out of Edit Mode. I'll then return the Y rotation to 0 and then tab back into Edit Mode. I'll press the Select button in the Vertex Group panel. I now have two sets of vertices in Group 2, one every fourth vertex running along the top of the plane, and one a diagonal selection of vertices. I'll tab out of Edit Mode. In the Shape Keys panel of the Object Data Editor, I'll click on the plus button twice to create a new shape key named Key 1. I'll then tab back into Edit Mode. I'll press the C key and then holding down my center mouse button, remove the diagonal set of vertices from the selection. Then holding down my Shift key, I will deselect the top right vertex and then select it again, making it an active element in the selection. I'll then set the pivot to active element. I'll then activate proportional editing. I'll press the S key and adjust the proportional circle of influence and scale the vertices down a bit. The circle of influence is about the upper third of the plane. I'll then press the A key to deselect the vertices. I'll then click on the Select button again in the Vertex Group panel to select the group's vertices. I'll press the C key and holding down my center mouse button, remove the top row of vertices from this selection. Then holding down my Shift key, I'll deselect the rightmost vertex and reselect it, making it an active element of the selection. I'll then press the S key, adjust my proportional editing circle, and scale down the selected vertices. The circle of influence is a bit short of covering the whole bottom of the plane. I'll then press the A key to deselect the vertices. I'll then tab out of Edit Mode. I now have a shape key that will move two sets of vertices of the plane, one across the top and the other at the diagonal. I will add a cloth dynamic to the plane object. I'll select the Silk preset. I'll check mark Pinning and select the Group to Vertex group. I'll open up the Collision panel and set the Quality to 3, checkmark Self Collision, and set the Self Collision quality to 3. I think this gives a better overall result. I'll then go to the Object Data Editor, and then I'll play the simulation. While the simulation is playing, I'll move the value slider for the shape key to the right. This has an effect of the plane gathering in folds. Before it reaches frame 250, I'll stop the simulation. The reason the cloth gathers in folds is because of the movement of the shape key, actually the movement of the vertices. With very little manual movement of the vertices via the shape key, the gathering will not be uniform. I'll let the simulation play out and restart at frame number 1. Notice that the gathering is not manageable. I'll stop the simulation and go back to frame number 1. I'll set my shape key slider back to 0 and play the simulation and move my shape key slider to the right. I'll then stop the simulation before it reaches the end. Here I have a fairly nice gather. I'll go back to the Physics Editor, and in the Cloth Cache panel, click on the Current Cache to Bake button. This will bake the simulation at this point in the simulation. I'll then go to the Modifier panel. Like soft bodies, Blender adds a cloth modifier to the object when the object is added to the cloth dynamics. Normally, I could just click on the Apply button and make a mesh of the current cloth simulation state. However, because this particular simulation uses a shape key, I cannot apply the cloth simulation. However, I can apply the cloth simulation as a shape key. I'll click on Apply a Shape Key. This applies the effect to a new shape key and removes the plane from the cloth simulation. I'll then go to the Object Data Editor. Here in the Shape Key panel is a new key named Cloth. I'll select key number 1 and move the controller to 0. I'll then select the Cloth key and move it up to get the gathered effect. Note that applying the Cloth modifier as a shape key removed it from the cloth simulation. I'll tab into Edit mode. The object is now a mesh in the shape of the gathered cloth simulation. I'll tab out of Edit mode, and I'll go to the Modifier Editor, and I'll add a Subdivision Surface modifier to the plane. I'll set the View and Render to 3. In the Materials panel, I'll set the Specular Intensity low, and I'll set the Hardness low. I now have a nicely modeled swagged curtain object. I'll go to layer number 3. Here I have modeled a circular plane object that has been smoothed. I'll select the plane and tab into Edit mode. As you can see, the plane is very dense with circular subdivisions. In Top View, I'll press the C key and circle select the center ring of vertices. I'll then open the Object Data Editor and create a new vertex group and name it Group 3. I'll then assign the selected vertices to the group. I'll tab out of Edit Mode and add the plane to the Cloth Dynamics. I'll select Silk as the preset. I'll set the steps to 15, and in the Cloth Collision panel, set the cloth quality to 3, checkmark Self Collision, and set the Self Collision quality to 3. I'll checkmark Pinning and select the Group 3 vertex group. I'll then play the simulation. This will take a while, but the plane vertices fall down along the z-axis and form a skirt-like arrangement. I will stop the simulation and go back to frame number 1. In the Outliner panel, I'll unhide a cylinder object. The plane object encircles the cylinder object. With the plane object selected, I'll hold down my Shift key and add the cylinder to the selection. I'll then press Ctrl P and make the cylinder a parent of the plane. Then, making sure that I'm on frame 1, press the I key and add a rotation keyframe to the cylinder. I'll go to frame number 50 and add another rotation keyframe. I'll go to frame 150 and I'll set the Z rotation to 720 degrees. I'll then add another rotation keyframe on frame 150. I'll then add collision detection to the cylinder object, and then play the simulation. This will take a while for Blender to build the simulation animation, so I'll pause this video tutorial until the cache is built. The cache is now built, and I am in frame number 1. I'll play the simulation. The plane vertices fall down along the z-axis. On frame 50, the cylinder starts to rotate, and the plane's vertices respond to the parent's rotation.